Sunil, please start.
Yeah. Hello and good morning, all the participants of Baroda book browsers. I take great pleasure in welcoming you all to this our first ever web-enabled book review. The name of the book is Miracle Cure, the creation of antibiotics and the birth of modern medicine, authored by William Rosen, late William Rosen, and the reviewer is none other than Dr. Rubin Shah. But before we begin with the proceedings of this book review, let me wish all of you, your family members, and the community in the neighborhood all the best for keeping safe, staying safe in the midst of the great calamity of public health crisis, COVID-19 pandemic, which is still amid us, and we do not know for how long it is going to continue to be with us. The lives are disrupted. Our peace has been, very, very badly affected, and the way we live our lives have already started to alter. After 22 years of uninterrupted physical meetings of book review at BBB, after February 2020, this great disruption in the form of COVID-19 has struck us, and we haven't been able to convene any Baroda book browsers meetings. But luckily, we have this technology-aided web platform available. And before I say anything, let me acknowledge our own member, Samir Parikh, and his colleague Sambhavi, Naman Associates, for making this Livestorm platform available for us for conducting web-enabled book reviews, as a result of which we are all hooked and riveted to the screen of our respected devices, and we'll be able to watch the proceedings in next 40 to 45 minutes. Just one or two small tips and clues to all the participants, although in the circular and notification mail that had preceded today, we have made certain clarifications and certain etiquettes, which I'm sure you would have perused, read, and understood. But nevertheless, let me recap them. During the book review and also after the book review is over, speech is disabled to all the participants. And therefore, during the course of this review and at the end of the review, if you have any questions or, short, brief view on the book or, the review carried out by Dr. Rubin Shah, please open the chat box, which is on the right-hand side of your screen. Put the text in the chat box. First, put your name and followed by, the brief narrative or, the question that you have. I will view the chat box and all the questions and views and put it up to Dr. Rubin, and he will answer. So this is the arrangement that we have to follow in this format of book review. About the book, of course, Rubin will deal with it at great detail. But I can tell you one thing, that the modern longevity of human life and ability to come to grips with myriad of diseases that became possible, can you believe, only in the last 60, 70 years, not until 30s and 40s of previous century. The allopathy medicine or the antibiotics, which is the propeller of an allopathy as a branch of medicine was available. And in all the countries of the world, the old alternate medicines were, in practice with varying results, and the success ratios were very, very minimal, and as a result of which lot of avoidable deaths used to occur. Can you believe this was happening in only 70 years back or 80 years back? Now that, in last 50 years and, this branch of medicine is still evolving, the longevity has gone up, the sufferings have, been minimized and mitigated to a large extent, and terminal sicknesses have been converted into a life-extending phenomena. So that's the great advantage of, this miracle cure antibiotics. Anyway, I'll not take much of its time, but let me tell you the graphic account or the historic events of this epic journey, as a result of which not only the alternate and most effective way of dealing with the human health has evolved, but how the associated health sector, pharma industry, the medical professionals, the insurance and other things have also developed and become one of the most flourishing sectors of, the economy in any part of the world. So that is the sum and substance of this book. But before I do the adieu and hand it over to Dr. Rumin Shah, let me say a word or two about Dr. Rumin Shah. Dr. Rumin Shah is a very renowned cardiovascular physician and diabetologist. And, he is considered to be, the ultimate in his diagnostic skills. Those of us who have been his friends and who have been also patients of him, we know, about his diagnostic skills and all those things. So as far as the professional field is concerned, but the most important aspect of this doctor's persona is that he's a voracious reader. But equally important, or even more important than that, is that he's a lifelong learner, not only in the medicinal field, but also in other fields. Thanks to the fact that, he has an unsatiated quench for acquiring more and more knowledge. He has so much of quest for knowledge that, he picks up lot many areas of interest, keeps updating himself. And then, people like me who interact with him, we are among the beneficiaries who keep enriching ourselves. So that's Dr. Rumin Shah for us. Now I request Dr. Rumin Shah, please take over the floor. I mean, not the physical floor, but the virtual floor. And please carry out the book review presentation. Over to Dr. Rumin Shah. Thank you.
Good morning, friends. Humanity today is in the midst of the most devastating global disruption in healthcare and an economic crisis. Just because of an invisible enemy, a coronavirus, it has brought the whole world to knees and put the world on a pause button. As we envisage a paradigm shift in the way we live, in the way we interact, it is so relevant that we are talking and discussing a book which is related to infections, which is related to antibiotics, and which is related to progress of medicine over the years. A disclaimer, the text in the review is completely and exclusively from Miracle Cure, as should be in any book review. However, I have taken liberty of adding few illustrations to make the review relevant and interesting. Yes, the book was published in 2017, has 310 pages. The most important thing, it has a bibliography of 15 pages showing the intense research and hard work that has gone into writing of this book. The author, William Browser, was an editor and publisher at Macmillan, Simon & Schuster, and the Free Prose for 25 years. As a part of his job, he acquired and published best-selling and critically acclaimed books, collaborated on half a dozen books, contributed to various newspapers, appeared on TV shows. Unfortunately, he died on April 28, 2016 at the age of 61 years of a gastrointestinal stromal cancer. The book was published after his death. To his credit, he has 4 other books most of them are narratives of industry narratives of how things and science have changed the way we live today. Now, what is the book about? The book Miracle Cure chronicles the history of medicine from bygone days of heroic medicine to germ theory of the disease, and then on to discovery of sulfa, penicillin, and other broad spectrum antibiotics. Viewing seamless narratives, William Rosen takes us from ancient Europe to England to USA and shows us the stories of scientists, their hard work, their failures, their successes in discovering antibiotics. How these antibiotics were discovered and changed the way medicine and medical profession is working today, and the way we live in, and the future challenges that we are going to face is very nicely depicted in the book. The book also tells us the shift of antibiotic research from labs to pharma company, and the flip side of antibiotic success story in the later part of the story. So this is the flow of the presentation today. We'll start with the first thing. The author starts with Smithsonian's National Museum of American History, which displays close to 10 million items. And he takes us to a 30-page document which shows the story of a lady called Anne Chef Miller. So what is so great about this in history of America? Yes, this lady had puerperal sepsis. She delivered on 14 February, and she started having fever, infection following pregnancy or delivery. She was found out to have streptococcal septicemia. The bacterial count was infinite. Whatever best was available in those days, blood, rattlesnake serum, and sulfa were tried. She did not respond. There was no way she would survive. The doctor treating there knew of a new drug known as penicillin, which was discovered in UK and had come to USA in small amount. So he took permission of National Research Council, and then he requested Merck and Company, which had totally 11 grams of penicillin with them. And he requested the company to provide some amount of penicillin for this patient. The patient, a month after her illness, on almost terminal deathbed, received 4-hourly intravenous penicillin by this doctor. This was the first time a patient in USA was treated with penicillin. Within 24 hours, the patient fever was totally gone. This patient, although was the fifth in the world to get penicillin, she was the first patient whose life was saved by this miraculous drug. And the author then takes us to flashback and shows us days of heroic medicine. He recalls how George Washington on 14 December 1799 was on deathbed. The best available physician in USA those days treated him. And what was the treatment? 60% of blood was removed from his body, considering that it was a poisonous blood. Irritant paste was applied on him so that pus would come out or the poison would come out of his body. Whatever did he have? He just had a bad tonsillar infection. Unfortunately, the removal of blood or irritant paste did not help him. He realized that he was dying, and he died on the same day. It takes us back to 1821 Napoleon, who was defeated in Waterloo. Again, was down, sick, terminally ill. And that point of time, the best physicians in France treated him with the conventional treatment. And what was the treatment? Hundreds of enemas and induced vomiting. Ultimately, Napoleon died, and the diagnosis was that he had either hepatitis or a doubtful stomach cancer. Remember, the best of the people in USA and in Europe, with the best of the doctors, did not get the proper treatment and therefore had to lose life. Well, it was not their fault. It was the science which was not properly advanced. Galen, a Roman physician in 129 AD, told that the disease in body are because of 4 humors: a blood, a flame, black bile, and yellow bile. Paracelsus, a Swiss physician, also said that disease is just because of imbalance in one of the 3 sulfur, mercury, and salt, cruelly reminding us of our Ayurveda, which again believes in imbalance as a cause of roots of all the disease. In fact, in USA, as late as late 18th and early 19th century, most of the doctors were homeopaths, hydropaths, and magnetic therapists. The standard treatment for a sick patient was to sit in a chair as shown in the picture, and the chair was then swilled, presuming that this would take care of his infection. Therefore, it was high time that something was done for such patients. The first ever big breakthrough came when a microscope, a very primitive microscope, and then a little advanced microscope were discovered in Europe, and that led to discovery of small animals known as animalcules, which could be causing infection. But the credit of finding out the roots or root behind a lot of disease goes to Louis Pasteur, a French scientist whose main interest was wine, saw that pasteurization of milk occurred because of and fermentation was entirely because of microscopic animals. It was not a chemical, it was a biological phenomenon. Incidentally, he treated a patient of rabies successfully, and therefore Louis Pasteur was almost a demigod in France. But he was the first to suggest that microscopic animals were responsible for diseases that we have. Another scientist from Germany, Robert Koch, most of the doctors know him very well, found out the cause of anthrax by injecting laboratory mice with fluids and purified culture from spleens of dead cows. For the first time established link between a microorganism and disease, that a microorganism, when it goes into body, causes a disease. He was the one who found out that tuberculosis was caused by Mycobacterium tuberculosis, so also the reason or the germ behind cholera. His Koch's postulates are very well known. Major contribution to surgery was by Joseph Lister, who found out that surgical sepsis, infection after a surgery, could be prevented by antiseptic and aseptic precautions and phenol and carbolic acid dressing. Louis Pasteur and Robert Koch, they were giants in those days. They were the pioneer scientists. They were the one who started or who brought in germ theory of disease. They realized that you require powerful tools, model for research, experimentation, and validation for a disease and the reason for disease to be established. Unfortunately, the politics, Pasteur being a French guy, Robert Koch being a German guy, they are arch enemies and they used to hate each other in everything that one would do.
અચ્છા એક
Now we come to bacteria.
સંબોધનને કહેવાનું છે કે અમુક લોકો એમ કહે છે કે પેલું માઇક્રોફોન નથી.
Ferdinand Julius Kohn, 1872, who labeled these microorganisms as bacteria. Bacteria have been existing for more than 3 million years. In fact, they were the only form of life on Earth till 750 million years. A gram of soil, 1 ounce of seawater contains huge number of bacteria. And these bacteria have this remarkable capacity of reproducing almost 3 times in 1 hour. They have capacity to mutate. The food that they require is simple: sunlight, chemicals, wood, and human body. And that is why to tackle a bacterial infection is not an easy job. It's goal that goes on changing every now and then. Fortunately, from 1874 to 1906, with the help of the germ theory that was put by Pasteur and Koch, a lot of diseases could be ascribed to the organisms or the germs, and we knew at that point of time that pneumonia, for example, was caused by Streptococcus pneumoniae, or syphilis was caused by so and so germ. And this is how, till from 1874 to 1906, it was feasible to find out the cause of the disease and not consider them as something which was remote or enigmatic. Now look at the year 1930, a year of human paradox. By 1930, humans were thoroughly modern. They used to fly. There were skyscrapers. They used to go and use great cars. Telephone was available. Einstein was coming out with his theory of relativity, and there were excellent movies. But what was lacking was healthcare. By 1930, humans were thoroughly modern, but at least in one way, they had advanced little more than prehistoric humans. They are almost helpless in the face of bacterial infection. In fact, Gladstone, a renowned physician from New York, said that by 1930, the universal opinion of physicians was that nothing could be discovered which would be effective against the diseases produced by bacteria. Nothing could be found out. And there was no way out. We have to face bacteria and we have to survive with them. But with newfound chemical knowledge and mechanical knowledge, the arsenal for conquest of disease was ready. Nature was no longer to be humbly accepted, but nature was an enemy and the germs were to be vanquished by whatever we had. Paul Ehrlich, a German scientist, was the one who pioneered staining of different cells and bacteria with different dyes. And he realized that if you need to tackle this bacteria, you need some chemicals. And chemicals would require chemical industries. He said the future of microbiology, future of treatment will be chemical. It won't be observational. And then he coined the word magic bullet. He said chemicals are going to be magic bullet, which would kill microorganisms and then would take care of diseases. In fact, his laboratory, after 7 years of hard work, introduced the first chemical known as salvarsan in 1910 and neosalvarsan in 1912. These were the first synthetic chemotherapeutic agents and used to treat syphilis. He told very clearly that success in research needs four things: luck, patience, skill, and money. And he was the one who was pioneer of starting chemical therapy of drugs. Then came sulfur revolution. A lot of German industrial conglomerate, they came together. Though in those days these were the finest German companies, they came together. And it was left to Domak, a physician who had worked in World War, and he realized the futility of working as a doctor in war zone when people were dying of infection. He went back to laboratory and he started meddling around with aniline and azodides. He did a lot of trials and errors from 1927 to 1931, and he came out with a drug known as sulfanilamide, which was available in those days as Prontosil. The drug was introduced and it became a raging success. In fact, the puerperal sepsis, the death rate was 30%, and with introduction of sulfanilamide, it went down to 4.7%. Truly, Domak, when he introduced sulfur, truly these were the first miracle drugs, and these were truly labeled as king of drugs. So there was immediate sulfur craze all over the world. People started manufacturing and marketing sulfur, and sulfur drugs were used right, left, and center in every possible infection. There were patients who would have died without treatment, but they improved within hours after treatment with sulfur. Domak went on to get a Nobel Prize. In fact, this drug also helped when there was a meningitis outbreak in Sudan, and Churchill's streptococcal infection was treated by this sulfur group of drug. The major implication of sulfur drugs was that medicine now was no more placid. It was off and running. A belief that doctors ought to be able to cure all infections came into existence. This transformed, ignited, and professionalized the healthcare, which so far was sort of heroic or a placid healthcare. Unfortunately, as it happens with everything, sulfur was used in excess, and a company in USA decided that if sulfur is good, more of sulfur is going to be better, and it introduced sulfur as a syrup so that it would not only take care of infection but improve appetite and improve well-being. This was a big racket. 73 people died because of misuse of this drug, and this brought into, at that point of time, Food, Drugs and Cosmetics Act, which is still relevant. But sulfurs were, as usual, over-marketed, and that led to a sudden pause in sulfur market. We come to penicillin then. It's well known that Alexander Fleming was a scientist who was the one who found out what penicillin was. It was 15 days after his vacation, that he went to his lab, saw a petri dish which was lying there, and there was one area in which staphylococci, which were supposed to grow, were not growing. It was a bald area on a petri dish. He was surprised. Why? He realized that the window was open and some fungus had come and crept into that. And that fungus possibly had stopped the growth of dangerous staphylococci. He labeled this as a mold juice. He believed that the mold juice or the fungus that was there had something known as lysozyme, which killed staphylococci. He knew that there was something, but Fleming's discovery was a classical dead end. That was it. He saw something, he reported it in 1929 in a scientific paper, but thereafter nothing more was seen. It was left to Howard Florey, a pathologist, an immigrant from Australia who went to UK, joined William Dunn School of Pathology at Oxford University, but he had an international exposure to Rockefeller Foundation. He believed in scientific research. He believed that scientific research should be international. He believed that competition should be between laboratories and not nations. And then he realized that there was some potential in penicillin, which was sort of discovered by Alexander Fleming, but was lying quiescent or was neglected. And to his help was Ernst Chain, a Jew, from Russia. He was a piano prodigy, but was paid very miserably. The pay that he used to get was 250 pounds per year. And he joined Florey, and then they started working on penicillin as a possible drug to combat infections. What was so great about Ernst Chain? Chain was a biochemist, but he had an inexhaustible flow of ideas and suggestions for overcoming difficulties. And he had ability to summon every pertinent reference in the scholarly literature of biology and chemistry. And that made him 1930s equivalent of a laboratory connection to the internet. He was sort of a Google. He would verbatim tell the paragraph, the number of page, and both of them, Chain and Florey, realized that penicillin was a scientific challenge and antibiotics were a virgin field, and therefore they decided to work on this. They did not have money, so they used bedpan for finding out how use bedpans of the hospital so that they could grow something and could work on chemically for the growth of penicillin. They, for the first time, isolated a substance that killed pathogens without damaging hosts. It was on 25th May 1940 that penicillin was isolated at Oxford. A successful mice trial was done, and it was shown that this drug was 20 times more powerful than sulfa. The problem was that it was most difficult to produce. They called companies like Glaxo, Bicam, and Burroughs to share their expertise. The companies were not interested in these stupid drugs. Incidentally, it was a day before Battle of Dunkirk started. So before the Battle of Dunkirk started, penicillin had been tried in laboratory animals. Yes, therefore, they were reported this in very well-known, renowned journal Lancet. And this came in 1940, that penicillin as a chemotherapeutic agent, and that concluded that the results are clear-cut and show that penicillin is active against at least 3 of the organisms, and that penicillin does not appear to be related to any chemotherapeutic substance at the present use. It is something different from the chemicals that we have been using. 17 January 1941, Eva Eckers was the first patient to be given injection penicillin at Radcliffe Hospital in UK, in London. And subsequently, after 3 weeks, Albert Alexander, having leg infection, was given this injection of penicillin, and both of them improved remarkably. A word about Dorothy Hodgkin. She was the one who, with the help of X-ray crystallography, could scientifically analyze the structure of penicillin. Now, what is so great about this? There are 2 things. This was the first British lady to get Nobel Prize for science, and till date, she remains the only female to have received Nobel Prize in science from UK. Not only that, she was a mentor of Margaret Thatcher, and Margaret Thatcher used to keep her photograph in her cabin. So this was the lady who gave us idea as to what was the structure of penicillin. If you look at timeline of penicillin, after 28, when Alexander Fleming first discovered, it was 1937 when Ernest Chain and Howard Florey started working on this penicillin project. 1940, they experimented with mice. 1941, the penicillin was first tested on human beings. 1942, government started to help. Now, question is, who deserved the credit for penicillin? Was it Alexander Fleming, or was it Howard Florey and Ernst Chain? And that controversy was raging because the teachers of Alexander Fleming and the St. Mary's Hospital claimed that it was Alexander Fleming who had introduced penicillin to world and he should get the credit. Florey and Ernst said that although he introduced, for 8 years it was a dead project, and therefore both of them should get the credit. Now, what is so great about this conflict between two? This shows that scientists ultimately have some motivation. Careers of a scientist, the author says, can rise and fall over a few days, difference in announcing even a minor discovery to other professionals. And scientists ultimately are human beings. The reasons for spending thousands of hours in poorly ventilated laboratories for poverty wages are complicated. It is just not much. They have this thrill of solving difficult puzzles. They get the joy of exercising their talents cultivated over a lifetime, and the pride and adulation that they receive after this discovery of the first discovery is unimaginable. Ultimately, the Nobel Prize for Physiology and Medicine in 1945 was given not only to Fleming, but also to Florey and Chain, because they were the one who actually took the drug from lab to patients. Now, Walter Florey himself was a great scientist, a great pathologist, very ambitious, and he knew that if penicillin has to become a good drug, Atmanirbharta is not going to work. So he looked beyond England, beyond UK, and he said, just being Atmanirbhar for penicillin is going to be a dead end. And therefore, with his context of USA, which he had because of his scholarship, he decided to go to USA and seek help from there. For example, the Medical Research Council of United Kingdom was asked some help for developing penicillin. And when they were asked to pay £600, the UK Medical Council paid just £25. They did not have money. They did not have infrastructure. It was philanthropy of Rockefeller, philanthropy of Rhodes, and collaboration with different departments that penicillin became an international phenomenon. So, Florey flew to USA, went to USA Department of Agriculture. The whole idea was to find out better seeds, better soil, better cultivation, and better harvesting, like you would do in any plant or for good crop of penicillin. And therefore, with the help of Department of Agriculture in Peoria, Illinois, there was a huge research work, Office of Scientific Research, Committee on Medical Research, and Hygienic Label. They made this as a project penicillin to make penicillin available to masses for treating infections. Now, it would have, and the first case we saw that she received this and survived. But penicillin got a big boost when there was a fire in Boston in a nightclub. 400 people died in that nightclub fire way back in 1942. And those who survived went to Mass General Hospital, were treated with penicillin, and almost all those who were treated with penicillin survived. Penicillin became a rage. The Department of Agriculture wanted to keep it secret, but then there were headlines in newspaper, 7 hours to live, and scarcest drug is rushed to baby and the baby survives. Penicillin was hailed as a dew of mercy. The penicillin project, which was supposed to be under wrap, became a sensational thing, and then they realized that penicillin has now come to market to patients. Most of the companies, Merck, Pfizer, Abbott, they were very small time players playing into morphine, citric acid, alkaloids, surgical anesthetics. and they were into small things. They realized the potential of penicillin. All major companies of USA were ready to participate in penicillin project, started putting their work into penicillin. And look at the result. There was huge anti-German hysteria. Pharma was restructuring. In 1920, pharma was the 16th profitable industry in USA, but Department of Agriculture, universities, and pharma research increased the pace of innovation in penicillin therapy. Most of the major companies spent huge amount of dollars to buy war surplus plants that were lying vacant. And by 1944, pharmacy or pharmaceutical industry was the most profitable industry, which was there for almost 20 years. Imagine an industry being so powerful for 20 years. There were 100 companies previously with just 3% national market. By the penicillin came, there were 20 companies with almost 80% market share. The market of pharmacology or drug market became tenfold. Immense contribution of penicillin in World War II cannot be forgotten. USA and Allied spent huge amount of money on penicillin. They had a huge capacity of manufacturing 650 billion units of penicillin. More than 100,000 many patients or soldiers who had infection benefited from penicillin treatment between D-Day and German surrender. Not only this, it saved thousands of lives during the last bloody year of combat in the Pacific. As compared to that, Germany was focused only on making gas for killing Jews, and its focus was on oil. It just contributed 25,000 marks for development of penicillin. And this penicillin in Germany, the amount of that they generated was 30 grams, which could treat only 4 dozen patients. Germany in short term lost more than 30,000 soldiers on Eastern Front because of infection and unavailability of penicillin. In fact, both Churchill and Hitler survived that infection because of penicillin. Thus, Germany got a big jolt because of penicillin, and US and Allied had an edge over Germany. You could see that in those days, there were ads that for a soldier, it is easy to get syphilis and gonorrhea. And if you look at World War II casualties, gonorrhea and syphilis were one of the causes, and both of them were helped by penicillin. A race against death, the faster this building is completed, the quicker our wounded men would get penicillin. So soldiers were helped right, left, and center by penicillin, and these advertisements became sort of very, very popular in those days. If you look at this, before 1920, 1930, huge number of patients used to die of lobar pneumonia, lung infection. It is after 40, an introduction of penicillin, that there is a remarkable reduction in death because of pneumonia. So also is syphilis and other sexually transmitted disease. Penicillin, for example, has changed the outcome of these bad diseases. Penicillin was a great drug, but there was a play too, because there was not much money to earn, because there was a huge competition. Companies started looking, and scientists started looking for something more than that. In the years that have gone, tuberculosis was a deadly disease. The only treatment was available was sanatorium treatment, fresh air, and good nutrition. But ultimately, patients would die of tuberculosis. It was Salman Waxman, working at Rutgers University, who saw that there was a huge potential of soil as a valuable source for growing bacteria. So this bacteria would be rich source of drugs. The idea struck him. Waxman was the guy who was the first to label these groups as antibiotics. He coined the word antibiotics. He told that antibiotics are drugs. These are chemical substances produced by microorganisms having capacity to inhibit the growth and destroy bacteria and other organisms. The hard work that he put in, he says that if you analyze 100,000 streptomycin strains, you could find out only one effective strain. And that is a huge amount of work, huge amount of experimentation and patience. The unfortunate part of this story is his relation with his student. His student Albert Schatz, who was a PhD student, whose thesis was streptomycin, did the groundwork, did a huge work at a very, very low pay of $10 a week, got samples, worked that, and his thesis on streptomycin was the one which brought streptomycin into market. Merck invested $3 million, and Mayo Clinic gave permission to start trials of streptomycin. Patricia Thomas on 15 November 1945 was the first patient to get streptomycin. Both Schatz, the student, and the teacher Waxman applied for patent for streptomycin in February 1945. Unfortunately, the boss, Waxman, was given credit. He got the Nobel Prize and patent money. And the student who had done the real drudgery did not get anything. Not to be bowed down, he sued his boss, and there was a compensation, and he got royalty, huge money, but science forgot him. And there are excellent accounts of how the teacher Waxman exploited Schatz, and there is a huge description of this controversy in this wonderful book. Another important thing about streptomycin is that this was the drug which brought the concept of randomized controlled trial, first ever time in science. Austin Bradford Hill, himself a doctor and suffering from tuberculosis, decided that, and in UK, decided that he wouldn't take this injection unless and until it is tried in number of patients. And therefore, this science of randomized control trial, and I'm sure all of us know how Abhijit Banerjee got his Nobel Prize because of randomized control trials in economy. But the concept of randomized control trial in medicine came way back in 1948 with streptomycin. And look at the effect of streptomycin. The deaths because of tuberculosis went down remarkably after introduction of streptomycin. Streptomycin thus was a major drug. It brought three things into limelight: the randomized control trial, a good drug controlling tuberculosis, and the hassles and the ego problems of the scientists. Now, the pharmaceutical companies realized that there was huge money in antibiotics, and it was left to Subbarao, an Indian immigrant working in USA, and Robert Woodward to explore broad spectrum antibiotics. Lederle, which was led by Subbarao, introduced aureomycin in 1949. This time, for the first time in history of medical science, came the role of marketing. 2 million samples worth $2 million were sent to almost close to 142,000 doctors all over the USA. They were all bombarded with samples. Woodward, another genius, introduced terramycin in March 1950. He then took help of 300 medical representatives, and they had 26% of antibiotic market share. Both the companies started doing reasonably well in antibiotics which were broad spectrum, working beyond penicillin. Broad spectrum antibiotics also brought patent system, and by 1952, because of broad spectrum antibiotics, United States was spending close to 100 million annually for broad spectrum antibiotics. The profit margin, which was almost negligible with penicillin, went up to almost 35 to 50%. This introduction of broad spectrum antibiotics was an unmixed blessing and final triumph of medicine over infectious diseases. There were ambitious physicians, brilliant physicians. Advertising business started coming into medicine, and the supply of miracle drugs like super antibiotics or broad spectrum antibiotics, these things change the practice of medicine forever. Now, having seen the success of antibiotic therapy, the author then goes on to the problems with antibiotic therapy. Haven't seen anything. If something is good, more of something is better. And Thomas Jukes, a leaderless scientist, believed that these antibiotics are just not good enough for infection. They can increase the growth of meat, growth of animals, and growth of human beings as well. So why use them only for infection? Use them for growth. In fact, a doctor in Florida started studying aureomycin and giving it to mentally disabled children for their growth. So this clearly was an overuse of drugs. A drug like terramycin used for animals, a drug like aureomycin used for animals just to increase their growth. And this was the first time that antibiotics in their went overboard and then create problems for themselves. Major blow to antibiotic lobby came after Park Davis introduced chloromycetin. Chloromycetin was introduced on 12th January 1949, and it was hailed as the greatest drug since penicillin. It could kill any organism. Basically, it was introduced for typhus, used extensively all over the world for typhoid fever. In short time, very short time, it captured a 36% of total broad spectrum business, and Park Davis became the largest pharma company with annual sale of almost $55 million. Between 1948 and 1950, more than 4 million patients were treated with chloromycetin. What more do you want? A drug giving great results, a drug capturing the market, and Park Davis was absolutely fine. But Park Davis and was overboard. And it was Dr. Albe Watkins in Southern California who lost his son James due to aplastic anemia caused by chloromycetin. He was very sure that his son was fine, had mild infection. He gave his son chloromycetin and his son never recovered. He died. He took upon him as a crusade to unearth the side effects of the drug. He stopped this practice, started moving from California to east towards Washington, visited each and every town and city of United States, went there, lectured the doctors and told that chloromycetin is a bad drug. But who was to listen to him? It was Admiral Elstrom, a newspaper baron, who lost his daughter because of complications of chloromycetin therapy. And he said that he would not leave this company. He started publishing articles in the newspapers that he owned against chloromycetin. Every patient who had suffered was depicted very vividly in this. They found out that there are 828 cases in 3 years because of chloromycetin toxicity. Now, the drug got a disrepute. Park Davis never was the same. And the only redeeming thing that it got was years later when he introduced Lipitor, again, then merging to Pfizer. But Park Davis had problems and chloromycetin was clearly the culprit. The antibiotic lobby was going so strong that a lot of people realized that pharmaceutical companies now were becoming dons. And it was Norman Cousins who started editing wonderful Saturday Review. And he said that, no, we have to take this lobby head on and ask his correspondents to write and expose these pharmaceutical companies. They found out that most of the companies were now doing aggressive marketing of drugs. Antibiotics were prescribed without a specific cause. It was prescribed in common cold, it was prescribed in viral infection. And this was reaching a disturbing proportion. There was a reflex prescription of antibiotics. A diagnosis was missed. Fever, give antibiotic. They could not trace the cause of the disease. Antibiotics created a lot of side effects. And they were also killing good bacteria, commensal bacteria that we have in our body. Between 1954 and 1958, there were almost 500 local epidemics in USA because of antibiotic resistant germs. And this, the authorities were supposed to look after the expose of Saturday Review. Companies which were not ready to invest hundreds of dollars in Dunn School for penicillin were spending millions of their money now for new drugs, for new antibiotics. The pharma company were very enthusiastic in promoting, but severely compromising judging the safety of their products. And you can see these drugs books have shown vividly the problems with pharma company. Thus, the outstanding achievements of the pharmaceutical industry on one hand, its business practices on the other hand, left a lot to say. Was it a fable of lost innocence? Miracle of antibiotics was at profound cost. This also was a morality tale of greedy pharma company, negligent physicians who would prescribe drugs without thinking once or twice, and the regulators which were truly impotent. They did not do anything to harness these pharmaceutical companies. And then came the role of FDA, Federal Drug Agency. FDA had a head known as Henry Welch, who was the head of antibiotic department of Federal Drug Agency. This gentleman was hired by a brilliant psychiatrist, Felix Martí Benza. This guy had come from Spain to USA and realized that there was a huge potential, unmet need of knowing what antibiotics were. From 1941 to 1948, so many antibiotics had come. Physicians did not have any clue as to what to use, when to use, how much to use, and when not to use. So he realized potential of educating physicians. He himself started some journals. He started journals one after another, and he appointed Henry Welch, the director of Division of Antibiotics, FDA, as editor. And this was a clear conflict of interest. The published journals then had stories about pharmaceutical drugs, companies, and antibiotics as panacea. There were advertisements singing praises of all antibiotics. This was a clear conflict of interest. They told that this is the third era of antibiotic therapy. There was an aggressive and irrational marketing of antibiotics. Antibiotics were given with fixed dose. They were given as combination with vitamins. And they said, who cares about FDA? It is the experience of one physician which should be counted. If I am comfortable with one drug, I should go on using it. So evidence-based medicine had no role, anecdotal medicine had role. Henry Welch, the FDA guy, received huge amount for his editorship, but Congress realized that this was a conflict of interest. He was forced to resign, but he so far is the poster boy for the dangers of corruption by pharmaceutical companies, bribing the authority and making the rules very compliant. So it was Fuller, a senator, who realized that pharmaceutical industry has gone so far, and he had a federal investigation which lasted for 21 months. And he found out, basically his idea was to find out why antibiotics were so costly. And he found out that the profit margin was huge, sometimes 11 to 27%. In one scenario, a John raw material cost was 14 cents, and the drug antibiotic marketed was at $15, which was almost 10,000% profit margin. So there are two issues. The drugs were overpriced, and the effectiveness of the drugs was very, very much doubtful. The Senate passed a bill to show that there has to be a proof of efficacy, safety of all new drugs, and certification procedure for all antibiotics. But the drug companies were non-challenged. They said, who's going to read and who's going to implement it? But for this brave lady, in those days, in Europe, a lot of pregnant ladies started using thalidomide. Thalidomide was used as for treatment of nausea, vomiting, and the birth that the pregnant ladies gave was of children who were phocomelic. They did not have arms. The drug company which was making thalidomide requested US FDA to permit them marketing thalidomide, a wonderful drug. Lady was very vigilant. She said, no, I wouldn't allow you to market. And therefore, when she put her foot down, it was found out that as compared to Europe, where there were close to 30,000 phocomelic children, in USA, there are hardly 30 to 40 children or newborn having phocomelia. She was prevented onset of a disaster in USA just by not allowing a drug into being action or available to mass. And this was a major victory of FDA. She then took the drug lobby head on. She realized.
Dr. Rumin, next 5 to 7 minutes?
Yeah, just 2 minutes. There was a disproportionate front-end expenses. There was a huge expense in source of antibiotics extraction, purification, synthesis. But the only expense that they made after manufacturing was to please doctors by giving them free samples and advertisement. There was, because of this lady, some procedure was set in, and she said that a drug has to undergo all these things before it is approved for use. Thus, there was a shift of power from pharma companies to federal regulators after her quest. if you look at the impact of antibiotics, if you look at United States from 1900 to 2000, the infectious disease deaths have gone down remarkably. In fact, the mortality rate from infectious disease has almost become so low, and the causes of non-infectious diseases have gone up. This is all thanks to great antibiotics available. If you look at this chart in 1900, most of the deaths were because of gastrointestinal infection, pneumonia, and tuberculosis. Now that has gone down remarkably. A major problem that now we see is drug resistance, and you see that drug resistance has become a phenomenal problem all over the world. There is antibiotic stewardship program, and there is Harvard-wide program to find out why there is so much of antibiotic resistance. Antibiotic resistant bacteria now affect close to 2 million patients in USA. There are more than 20,000 deaths, and you can imagine the number of patients in India. Most of the hospital-acquired infections are antibiotic resistant. This is all because of subtherapeutic dose, overuse in animal feeds, overuse of antibiotics, and even as of today, 50% of hospital physicians have inappropriate or unnecessary antibiotic prescription. 40% of patients don't take treatment properly, and there is bacterial mutation. Now, if you look at discovery of drug, if you look at from sulfa to the other drugs, from almost last 40 years, there are not many new antibiotics which have come into market. If you look at the drugs, there is hardly new antibiotic in last 30, 40 years. Pharmaceutical companies now, which were built virtually on the platform of antibiotic, now barely have some antibiotic in their portfolio. So antibiotics are barely a rounding error in the industry's balance sheet. None of pharma charter members of penicillin make antibiotics. From 1938 to 2013, 155 antibiotics were approved, but only 96 of them are available. And although 2012 was the best year for new drug approval, and 37 new drugs were approved by US FDA, not a single antibiotic was approved. Our drug development cost is close to 400 billion, 43 billion, and this is one which is a stumbling block. If you look at the future of antibiotics, there are novel ideas, novel ways by which people are going to be treated with antibiotics. Stanford Microbiome Therapies Initiative and scientists are working to find out ways to address antibiotic resistance, ways to attack bacteria, and ways for developing new antibiotics. I just take last two slides to show the prose, the wonderful prose that the author writes. He writes that Alexander Fleming was an avid player of snooker and croquet, a skilled rifle shot golfer, painter. He used to say that I always play with microbes. Norman Hitley was a mechanical genius, was a tall, elegant, slender, diffident, and courteous, and had great talent for building lab equipment out of spare parts and discard. Tischler was born with energy level that was like an avalanche and a brain that was incandescent. This is the writing of William Rosen. Feldman was extremely imaginative, able, wonderful scientist, and a very dedicated and prolific writer. Ellie Lilly, the owner of Ellie Lilly Pharma, was amateur archaeologist, sophisticated art collector, compulsive writer, and so on. And Pat Davis guy, who resisted chloremphenicol issue, was aggressive, disciplined, autocratic, impatient with mistakes, and possessed enormous energy. And these are some of the good points or the beautiful prose that the author has used. The book is about evolution of medical science without boundary, history, politics, war, the shift of power from Europe to USA, the shift of chemical industry to pharmacy, evolution of pharmaceutical industry, evolution of economic, commerce, and marketing, philanthropy, making a huge role. There is a mini biography of almost all the scientists. There is a description of human virtues and foibles, greed, perseverance, animosity, ego, pride, greed, and errors, and talent. If I have to say that some message, the germ theory of diseases led to antibiotics, hard work and perseverance of scientists led to successful anti-infective therapy. Sulfa, penicillin, streptomycin, and broad-spectrum antibiotics have truly changed the disease management outcomes and improved our life. Pharma industry became powerful after antibiotic therapy, but went overboard, leading to upheavals in antibiotic therapy. Antibiotic resistance is a major concern, and future journey of antibiotic is little arduous, but going to be helpful to us. There are three good quotes. Enemy in this war may lose individual battle, the germ, but the war against it is eternal. Antibiotics are victims of their own dramatic effectiveness. And if you want flawless heroes, a scientist, it is best to stay in the fiction sector. I thank Dr. Vasanbhai Patel, senior physician of Baroda, for gifting me the book. Samir Parikh, CEO of Naman HR, and Shambhavi Trivedi for giving us a wonderful live stream platform. Sunil Bhai and Baroda Book Browsers, I'm a part of the family, but still I would thank them, and I would thank all attendees today. If there are any questions, I would be pleased to answer. Thank you so much.
Yeah, thank you, Rumin Bhai, for a very splendid, competent, and fluent rendition that captured the entire drama and the whole sequence of, the quest of the scientists, how their egos, their collaborations, their ambition, and their inner resolve overcame the barriers and impediments before antibiotics have come to, become the central force of medical treatment as it is today. And for this wonderful effort on behalf of every participant, let me virtually clap and acknowledge your this great presentation. And the number of graphics, the pictures, and appropriate narratives that you have put in the slide reflect not only your digestion of the entire book, but also, the mastery or the skills that you have in your own medicinal field. Thank you. Wonderful effort, Rumin Bhai. And now is the time to put up questions to you. There are a couple of questions. The question number 1 and 2 are more or less similar. One is from Himanshu Shah and the other one is from Chirag Bakshi. What their question is that the continuous or very frequent use of antibiotics make them ineffective. And Chirag also says the same thing, whether bacteria get immunity on account of, their frequent use of antibiotics on them. So that's the question, common question. Over to you, Rumin Bhai.
Absolutely. There is absolutely no question that there is overuse and abuse of antibiotics in a number of viral infections, and therefore physicians go overboard in treating patients. So there is on one hand abuse. Second, as I showed that there is incomplete course of antibiotic, but bacteria being so smart, they mutate so fast, they develop enzymes which inactivate antibiotics. And that is the reason we see a lot of antibiotic resistance nowadays.
Good, thank you. I think the next question is from Tailap Shah. Rumin, question for you. Before onslaught of corona, that is COVID-19, most of the world thought that almost all that was to be discovered had been done with. Corona has brought entire science and medical community again into a huddle to combat this great disease. What are your views?
Corona itself is a very fluid subject. Research is going on. Every day a new theory comes. The treatment that is going right now is not scientific, it is anecdotal treatment. Evidence-based treatment would require a huge number of studies, and therefore it is hit and miss treatment. But corona, if I'm not wrong, will be a part of our life. We will have to start living with it. That I don't know whether that has answered or is that a sufficient answer or not?
Okay, Rumin, the next question is from Harit Kumar Bharat. Antibiotics also cause acidity and other digestion issues. The body doesn't get used to antibiotics. Organisms turn resistant. Something like a subset of that earlier question, but this is the question.
Antibiotics, because, for example, a drug like amoxicillin or ampicillin will destroy commensal bacteria living in stomach and the gastrointestinal tract. This in turn would cause diarrhea and therefore a gastrointestinal upset. There is a common practice, although not very scientific, to give probiotics to such patients. But although it is not very scientific, it works in some patients, and that helps mitigate the side effects of antibiotics.
Yeah, Dr. Tailap Shah's next question is that do say something on corona and its cure. would it be nice to
Oh,
hear from a leading and practicing physician? He keeps giving you compliments, doctor?
yeah. Corona is going to be a part of life. The serious patients are going to have trouble in recovery simply because of the way of cytokine storm and clotting of blood inside. The science is still in dilemma whether it is cytokine storm, whether it is infection with his lungs, or it is just predominantly blood clotting that is creating problem. But all said and done, corona is, those who are very critical are going to face trouble, and the mortality rate, although is going to be close to 2 to 3%, 85% of corona patients are going to be all right with simple treatment available today: azithromycin, hydroxychloroquine, and so on.
Yes, doctor, this next question is from Shashi from Bangalore. It's a very pertinent question and something, which all patients like me also, keep confronting. Why is it necessary that administration of, the antibiotics has to be put through to its complete course and not interrupted, even if the patient is feeling okay and, is all right? What happens if the course is not completed? Does it not work the next time?
The first thing is that most of the antibiotics would kill a germ working at various levels, either the cell wall or the enzyme inside or various parts of the cell of the bacteria. Now, some of the germs remain dormant, and once you stop the course in between, for example, 3 days instead of 5 days or 5 days instead of 7 days, those dormant bacteria have ability to relapse, and this is one reason why there is a huge amount of antibiotic resistance and can lead to a relapse earlier or later on. Tuberculosis is just a great example. The treatment has to be continued for 6 months in some cases, but mostly 9 months. Otherwise, the dormant bacteria could do a resurgence and create problems.
Yeah, and I think the next subset is, I know pharmaceutical industry does have done one good thing, and that is that they have provided me good constant employment. That's a remark.
Yeah, absolutely.
Yeah, correct. So there are some more questions. They are in the question box. I'm just running through them. Of course, this Tailapsa is very active. He says, are doctors to be blamed for overuse of antibiotics?
Yes, yes, yes.
If it is a professional hazard, you can skip the question or you can skirt
No,
it
no.
around.
The book also says that doctors overuse, and the practice also says that there is a huge overprescription of antibiotics, both outdoor and indoor patients, and this has been the cause of antibiotic resistance also. But the dilemma that a doctor faces is very odd, having patient wanting a cure as early as possible and limitation of investigations makes it a very dicey situation, and that is how antibiotic stewardship is coming up and there are ways and means of monitoring the antibiotic prescription and ways and means of controlling antibiotic prescription. Most of the hospitals now have started antibiotic stewardship, and if you prescribe a drug which is very strong or totally out of the context, the hospital does take objection, and then there is an antibiotic stewardship committee which then wants your opinion as to why do you want to start. So there are restrictions, and there is science now coming into managing such situations.
Rumin, next question is from Satish Pandya. He
Yeah.
says that antimicrobial resistance, AMR, is a raging issue, and antimicrobial stewardship is the answer. And Rumin, can you please tell us what is the status of the stewardship in Baroda hospitals?
Yes, antimicrobial stewardship is a group effort of the microbiologist, the pharmacist, the physician, and the intensivist. Depending on the pattern of organisms that they grow, depending on the culture sensitivity report that show, this stewardship will direct the clinician to start or stop the treatment or question him, and will guide in rational therapy decisions. This antibiotic stewardship, to the best of my knowledge, is existing in at least 3 hospitals of Baroda, and they are reasonably successful program led by some very competent people.
Yeah. Next question is from Surendra Sundar Rajan. There are 2-3 more questions, and after that, number of compliments. As it is, there are a lot of encomiums about Rumin, for your professional competency and your knowledge. So I'll quickly read through them. But before that, there are 2 or 3 questions. One is from Surendra Sundar Rajan. Very engaging review. Does the book dwell on the challenges to antibiotics from superbugs, a relatively recent concern?
So there are 2 issues. One is TDR, or something known as total drug resistant tuberculosis, and New Delhi metroprotease. So there are 2 superbugs seen exclusively, one in Delhi variety and the second is in Dharavi slums of Bombay. Now there is a mention of superbugs and there is a way and how to tackle them. It hasn't gone into details because the book was published in 2017 and superbug literature has come almost at the same parallel time. But there is a mention of the danger created by superbugs.
My request to Dr. Rumin Shah, can you switch off the slides so that you are more accurately and more completely visible on the screen? You can switch off the slide. Yeah, that's it. Thank you. So there is a lot of compliments. I will send you the screenshot of all these things. But let me take the questions. There are questions. Yeah. Last question from Tailab, but I will take the last. Before that, there are some questions. Sagar Mehta, Rumin, thank you very much for your very engaging and engrossing review. Good participant and very informative. Have a nice, okay, this. Oh, these are all compliments, but there are some questions in the question box. 1 minute, just hold on. Yeah, this must be from Vikram Singhal. Yeah, okay. It seems that most major discoveries on antibiotics happened in the diddle of 20th century. And does the book talk about the reasons for this in the diddle of the 20th century? That is the second half of the 20th century. Does it talk about why it happened during the second half of the century?
Well, actually, it was a need-based solution. The pharmaceutical companies, the infections were not going away. Companies were looking for drugs. Penicillin came, gave excellent results, and therefore the horizon expanded, started getting broad-spectrum antibiotic. And the other antibiotics, for example, macrolides and chloromycetin. Thereafter, so there was a growth because there was a need to treat multiple infections. Thereafter, there are 2 major reasons for not, or sort of it is almost zero growth of antibiotics. One of them is enormous cost in developing these drugs. Number 2, the returns of antibiotic therapy, because it's a short therapy, is very low as compared to a lifestyle drug. For example, a blood pressure drug or a diabetes drug, which would go on for life. Antibiotic course is for 7, 8, 10 days. And that's the reason that the margins may not be so good and the return may not be so good for a pharmaceutical company. And that is the reason that only 2 groups have come. Most of this invention was actually a need-based invention with the help of aggressive science and help of pharmaceutical companies as well.
If I may add to that, Dr. Rumin, you see, if you look at the most important discoveries or increase in the comforts as well as the advances in the technology that have ever taken place in human history, it is only in the last 50 years of 20th century. And when the historians will write, it will go down as, probably the most productive half century, ever. Save and except, of course, now the 21st century, the first 20 years are, exploring and, doing things which were not believable, only 30, 40 years back. So I think 20th century, second half, in many ways is the game changer for the way the human beings live, the way human beings, progress, and the way human beings enjoy comforts. But 21st century is set to, probably overtake, the second half of the 20th century. That's my take. No more questions. There is one query. Hitesh Gala. I enjoyed the book very much. Can I have the PDF version of this book, Rumin Shah? If you have the source, you can just...
Sure, I will. Sure. Sunil, there are just two questions that I see. One is from Narendra Hindocha.
Yeah.
Can you throw some light on drugs which are evolving? Yes. 2 or 3 group of drugs are coming out for treatment of resistant antibiotics. Most of them are variants of the existing drugs. For example, a new cephalosporin, or for example, one new beta-lactamase, or for example, one new carbapenem. The same groups are same. It is a new group drug. None of the new groups are coming up. There were only 2 groups which came. One is daptomycin and the second one is linezolid. So these are the 2 groups which have come. Most of the other drugs are sort of extension or brand extension. There is one question from Shardul Bhatt. Are these there are any superbugs resistant to all known antibiotics? Yes, there are superbugs which are resistant to all known antibiotics, and they are known as TDR, total drug resistant organisms. There is one question on your take on bacteriostatic bactericidal antibiotics. Bacteriostatic antibiotics are one which just cause stasis or stop growth of antibiotics. Bactericidal antibiotics are one which kill antibiotics. And any day, bactericidal antibiotic is good, provided the side effects are low.
Yeah, I think that's all about some questions are there, but I think we are running out of time. And in fact, there are a lot of compliments, and many participants who are not in Baroda have acknowledged that, thanks to this forum, they will be able to participate, and they were regretting how they could not attend earlier the physical meetings. In the era of projections, optics, and data and statistics, how can I forget not to mention the number of participants? We have crossed 160 plus participants in this first ever web-enabled book review by Baroda Book Browsers. On this note, I would like to adjourn and conclude the meeting without not mentioning, of course, that till such time as the calamity created conditions prevail, we will resort to this web-enabled meetings. But I'm sure, the physical format of the meetings will be upon us, and we'll get back to our physical meetings soon, hopefully. It seems maybe up to July, August, we'll have to continue this web-enabled meeting. Continue to support us. Continue to stay tuned in. Thank you for your wonderful participation, even if you were not able to speak because of, the certain technical issues. And, we are just getting acclimatized with this format. Maybe in the next format, we can try wherein, the questions can be directly put up by the participants to the reviewer, and the reviewers can find the questions themselves. On that note, have a wonderful remainder of Sunday. Continue to remain safe. Continue to take care of yourself. Have a nice weekend. And thank you, Rumin. And thank you once again, Samir and Sambhavi, for great support. Without your bedrock of support, this first ever meeting would not have been able to accomplish. Thank you so much. Thank you all, once and all. Sambhavi, you may now tuned out. Thank you.